Before I give you more examples, let us recall the general power rule. The derivative of a power of u, or u to the n, is equal to n times u raised to n minus 1 times du, where du is the derivative of u and u is the base of the power. Now let's continue with our examples. Now we have the function y equals the square root of x squared times the square root of 1 plus x squared. First, we write our function using rational exponent. It's now y equals x squared times 1 plus x squared raised to 1/2. Now this quantity is raised to 1/2 also. So for us to be able to use the general power rule, we have to write our function in the form u to the n. So the base must be equal to u, the whole base. This x times the quantity 1 plus x squared raised to 1/2 is equal to u. Okay, so now y in terms of u is u raised to 1/2. So we can therefore use the general power rule to differentiate this function. So the derivative of y with respect to x. Remember that originally y is in terms of x. So y with respect to x is equal to, using the general power rule, you bring down the exponent, copy the base, subtract 1 from the exponent. So that's going to be 1/2 minus 1 times du. Okay, now we just have to write u in terms of x. So in terms of x, y prime is equal to 1/2 times u is x squared plus, no, it's x squared times 1 plus x squared raised to 1/2, and the exponent 1/2 minus 1 is equal to negative 1/2 times du. So that is the derivative of u, where u is x squared times 1 plus x squared raised to 1/2. And so we continue with the differentiation process. Every time that you still see d in your equation, it means that you don't stop differentiating yet. And also simplifying this expression, because that the power is raised to a negative exponent, we have to make the exponent positive 1/2. So we have to write this whole expression in the denominator, okay, beside 2 in the denominator. So that's going to give us y prime equals 1 over 2 times x squared times 1 plus x squared raised to 1/2. This time it's raised to positive 1/2. Okay, we take the derivative of x squared times 1 plus x squared raised to 1/2 next. Now, as we can see, this part of the equation, the part that we have to differentiate, is in the form of a power of x squared and 1 plus x squared raised to 1/2. So in the power rule, okay, this is u and this is v. All right, so it's a product of x squared and 1 plus x squared raised to 1/2. Now recalling the product rule, the derivative of u times v is equal to u dv plus v du. Okay, that's what we're going to use to differentiate this expression. U is very easy to differentiate. So u is just x squared. So when we differentiate u with respect to x, we'll just get 2x. But v is a power of 1 plus x squared. Okay, so it's raised to 1/2. So again, we have to use the chain rule to differentiate v. So just have to make sure that dv is correct. So what is dv equal to? Our v is 1 plus x squared raised to 1/2. Okay. So to be able to use the general power rule, we have to write this v in the form u raised to n. Okay, so u will be our base, 1 plus x squared. So in the general power rule, we just have to bring down the exponent, copy the base, subtract 1 from the exponent, and then take the derivative of the base. The base here is 1 plus x squared. Okay, so dv is equal to 1 half times 1 plus x squared raised to negative 1 half. The derivative of 1 plus x squared is, of course, 2x. Okay, simplifying dv, we have 2 over 2 equals 1, so we just cancel out 2. And then we have to make the exponent negative 1 half positive, so 1 plus x squared raised to 1 half will go to the denominator, so this is dv. And what remains in the numerator is x. Okay, and in the denominator we have 1 plus x squared raised to 1 half. So this is our dv. So continuing in y prime, derivative of u times v. Okay, recalling this formula, it's u times dv, where u is x squared. Okay, u times dv. dv is, we already obtained that, it's x over 1 plus x squared raised to 1 half. Okay, plus v. Remember, v is 1 plus x squared raised to 1 half also, times du. So if u is x squared, du is 2x. Alright. We are done with the differentiation process. What's left for us to do is simplify our answer. So go here, y prime equals, okay, just copy the first factor, 1 over 2 times x squared times 1 plus x squared raised to 1 half. This quantity raised to 1 half. Okay, let's simplify the expression inside the set of brackets. We have here x squared times x. That will give us x cubed. So that's going to give us x cubed over, that's 1 plus x squared raised to 1 half. I'm just copying. And then I'm just rewriting the second term inside the bracket. It's 2x times 1 plus x squared raised to 1 half. Okay, now we have to simplify this expression inside the bracket by getting the LCD. So again, copying the first factor, x squared, 1 plus x squared raised to 1 half, raised to 1 half. Taking the LCD inside the bracket, we only have the denominator 1 plus x squared raised to 1 half. Okay, so the first term is still x cubed. The second term would be, so plus, so that's going to be the LCD times this quantity. So 1 plus x squared raised to 1 half times itself will give us 1 plus x squared. Okay, so 1 plus x squared raised to 1 half times 1 plus x squared raised to 1 half is equal to 1 plus x squared. Alright, so the second term is just 2x times 1 plus x squared. Now simplifying further by removing the grouping symbols, 1 x squared, 1 plus x squared raised to 1 half raised to 1 half. Okay, removing the grouping symbols by distribution, you'll get x cubed plus 2x plus 2x cubed over 1 plus x cubed, x squared raised to 1 half. Simplifying further by combining like terms inside the grouping symbols. Let me just rewrite everything. So combining x cubed and 2x cubed will give us 3x cubed plus 2x over 1 plus x squared raised to 1 half. Okay, now multiplying the denominators and the numerators. Okay, I will use some color coding so you will not be confused. This part is green, so I'll be simplifying that in the next line. And the encircled portion, x squared and 1 plus x squared raised to 1 half are both raised to 1 half. So it's x squared raised to 1 half, and then 1 plus x squared raised to 1 half raised to 1 half. Okay, so I've just rewritten the expression inside the brackets. Let me erase the bottom part so that we'll have more space for our solution. And rewriting our answer. It's 1 over 2. X squared raised to 1/2 is simply x when we simplify. Let me use the same color. So this is x. And then 1 plus x squared raised to 1/2 raised to 1/2 is just 1 plus x squared raised to 1/4. Okay. Now we just have to write our final answer as one rational expression. So we just multiply the numerators and the denominators. And we'll get for y prime. The numerator is just 3x squared plus 2x, but then there's still a common factor there, which is x. We can factor out x from the two terms in the numerator. So factoring out x from 3x squared and 2x, we'll have the x times the quantity 3x plus 2 over the same denominator 2x times 1 plus x squared. Or we can now multiply 1 plus x squared raised to 1/4 and 1 plus x squared raised to 1/2. And that's going to give us 1 plus x squared raised to 1/4 plus 1/2 is 3/4. Okay. And then x over x is equal to 1. So this will be cancelled out. Okay. And so our final answer would be y prime equals 3x plus 2 over 2. Now writing our final answer as a radical, 1 plus x squared raised to 3/4 is just 4th root of 1 plus x squared raised to 3 or cube. This is the derivative of the function. If you'll notice, the differentiation part stopped here at this. And then all this is just for simplification of the final answer. One last example. So in this function, so the function is a fraction or a rational expression. So to differentiate this, we have to use the quotient rule. So our main formula here is the quotient rule. So let us just recall the quotient rule. The derivative of u over v is equal to v du minus u dv all over v squared. Okay, so in this case, this is u and this is v. So the function is now a quotient of u and v, where both u and v are in terms of t. So we differentiate, so du and dv will both be in terms of p. Okay, so let's just rewrite. U is equal to t squared plus 1 raised to 1/2 if we'll be using a rational exponent, and then v is equal to t plus 2 raised to 4th power. So to differentiate u and v with respect to t, we need to use a chain rule for both of them. Okay, let's start with du. Using chain rule, I hope you remember now. Chain rule, or the general power rule. So u is a power of t squared plus 1. So in the power rule, what we do is bring down the exponent, we copy the base, and subtract 1 from the exponent. Don't forget to take the derivative of the base. In this case, the base is t squared plus 1. Okay? So we'll continue. Simplifying 1/2 t squared plus 1 raised to negative 1/2. Remember that we are differentiating u with respect to t here. So we can write the notation du over dt also. Okay? So the derivative of t squared plus 1 with respect to t would just be 2t. Okay, simplifying, 2 over 2 is 1, so that's just equal to 1, so we can just cancel out 2, and then what remains in the numerator is t. To make the exponent of t squared plus 1 positive, we have to write t squared plus 1 raised to 1/2 in the denominator, so it's t squared plus 1 raised to 1/2. Okay, so this is du with respect to t. Okay, so du and du over dt are just the same. So du over dt is just very specific that we are differentiating with respect to t, right? So now let's go to dv. dv, using the chain rule or the generalized power rule, which is derived from the chain rule also. So it's 4 times t plus 2 raised to 4 minus 1 times the derivative of the base t plus 2. Okay, we are differentiating v with respect to t as well. Simplifying dv, it's 4 times t plus 2 raised to 3, and the derivative of t plus 2 with respect to t is just 1. Okay, so dv over dt is equal to 4 times t plus 2 cubed. Okay, so let's continue. So the derivative of y with respect to t using the quotient rule is equal to, our v is using this formula. Okay, I boxed it above. So v is equal to t plus 2 raised to the 4th, while du is equal to t over t squared plus 1 raised to 1/2. And in the formula, next is minus u, where u is t squared plus 1 raised to 1/2, times dv, where dv is 4 times t plus 2 cubed. And this is all over v squared, where v is t plus 2 to the 4th. Okay, we square that. Okay, we're done with the differentiation process. All we need to do is simplify our answer. So what we have here is a complex fraction that we need to simplify. Okay, this portion first. Multiplying the numerators there, that's t times t plus 2 to the 4th over t squared plus 1 raised to 1/2. Okay, now this, just rewriting that, so it's minus 4 t squared plus 1 raised to 1/2 times t plus 2 cubed, and then all over the same denominator, t plus 2 to the 4th. Now let's simplify the denominator. T plus 2 to the 4th squared is just t plus 2 raised to 8. Now we combine these two using the LCD. Okay. Okay, this is still the denominator t plus 2 raised to 8. Now in the numerator we only have one denominator, so it's just, the LCD is just t squared plus 1 raised to 1/2. Alright, so the first term there is still the same because it has the same denominator as the LCD. So minus, now this must be multiplied by the LCD. Okay, so the LCD t squared plus 1/2 plus 1 raised to 1/2 multiplied by this is just equal to 4. So we have t squared plus 1/2 times itself. So again, that's t squared plus 1. Oh, I mean, this is t squared plus 1 raised to 1/2. So multiplied by itself will just give us t squared plus 1 times t plus 2 cubed. Okay? Let's continue. Now this and this both go to the denominator. So now the denominator is t squared plus 1 raised to 1/2 times t plus 2 to the 8. And then the numerator is t times t plus 2 to the 4th minus 4 times t squared plus 1 t plus 2 cubed. We don't want to expand this anymore because they have high exponents or large exponents. So what we can do here is just factor out from these two terms, factor the common factor, which is, the common factor is t plus 2 cubed. Okay, so factoring t plus 2 cubed from both terms. Okay, from here, factoring t plus 2 cubed, we'll have t times t plus 2. Okay, so subtracting 3 from 4 because we have factored out t plus 2 cubed already. So what will be left there is the exponent 1 to t plus 2. So minus 4 times t squared plus 1 because this has been factored out. Okay, over t squared plus 1 raised to 1 half times t plus 2 raised to 8. Now this 2 can be divided. So if we divide, they have the same bases. We just subtract their exponents. Okay, so this becomes, subtracting the exponents, 3 minus 8, this becomes 5 here. Alright, so this will be eliminated from the numerator, and the numerator will now have t times t plus 2, this portion. I'll just copy everything. And then the denominator is t squared plus 1 raised to 1 half. Upon dividing t plus 2 cubed and t plus 2 raised to 8, we'll have t plus 2 to the 5th. Okay. Now, removing the grouping symbols in the numerator, distribute t. We'll have t squared plus 2t. And then distributing minus 4, we'll have minus 4t squared minus 4. All over t squared plus 1 raised to 1 half times t plus 2 to the 5th. Combining like terms in the numerator, we'll have a negative 3t squared. So t squared minus 4t squared is negative 3t squared plus 2t minus 4. And then we'll have to write t squared plus 1 raised to 1 half as a radical. Okay, so we have t plus 2 raised to the 5th power. In the form of a radical, t squared plus 1 raised to 1 half is the square root of t squared plus 1. This is the derivative of y with respect to t in simplified form.